All right, let's talk about machine learning. You hear this term everywhere, and it can sound pretty intimidating, right? But what if I told you it's not some far-off sci-fi concept, but a kind of magic you're already using every single day? We're going to pull back that curtain and see exactly how it works. Let's get into it.
I mean, really think about that for a second. How does your phone, your streaming service, your favorite app, how does it seem to have this sixth sense about what you want? That feeling, that uncanny prediction, that's the mystery we're going to solve today. And spoiler alert, the answer is machine learning.
You know the feeling. You just finished binge watching a show on Netflix, and boom, right there on the home screen is your next obsession. That is absolutely not a coincidence. That's a sophisticated machine learning model that's learned your taste in movies better than some of your friends. Or how about this? The simple, beautiful piece of an inbox that isn't overflowing with junk. That's a silent hero at work. Every single day, a machine learning algorithm is sifting through incoming mail, recognizing patterns, and making sure that only the important stuff gets to you. And anytime you use an app like Google Maps to outsmart a traffic jam, you're using machine learning. It's not just a map. It's a living system, analyzing real-time data from thousands of other phones to predict where the slowdowns are and find you that clever shortcut. This stuff is already totally integrated into our lives.
So, how in the world does this actually work? Well, it's not magic, but it is a massive fundamental shift in how we tell computers what to do. We're talking about the code that literally writes itself.
Okay, this slide right here, this is the whole ballgame. This is the big idea. For decades, programming worked one way. A human programmer wrote very specific rules. If this happens, then do that. You'd feed data into those rules and you get answers. Simple. But machine learning completely flips that on its head. We give the computer a ton of data, and we give it the answers, and we say, okay, you figure out the rules. Instead of us teaching the computer learns for itself.
Now, to really get this, we just need to know a couple of key terms. First up is a feature. The easiest way to think of a feature is as a clue. It's a piece of data, an attribute that we give the machine to help it solve the puzzle. So if we're trying to predict the price of a house, a really important feature would be, say, the number of bedrooms.
And if the features are the clues, then the label is the answer we're looking for. It's the solution to the puzzle. So, sticking with our house example, the features are things like the number of bedrooms, the square footage, the location, and the label, that's the final selling price.
And finally, you have the model. The model is the engine that puts it all together. It's the system that we train by showing it thousands or even millions of examples of features and their corresponding labels until it starts to understand the relationship. The model is the thing that learns. It becomes our rule maker. So it turns out learning can happen in a few different ways. Machine learning isn't just one monolithic thing. It comes in a few different flavors, and each one is perfect for solving different kinds of problems. First, you've got supervised learning. This is pretty much like studying for a test with an answer key. You give the machine a massive data set where everything is already labeled. For example, millions of emails, and each one is clearly marked as spam or not spam. The model studies these examples over and over until it gets so good at spotting the patterns that it can label a brand new email all by itself. Next up is unsupervised learning. Now with this one, we take away the answer key. We just hand the machine a giant, messy pile of data and say, find something interesting in here. It's like giving someone a huge bag of mixed up fruit and asking them to sort it. They naturally start making piles of apples and oranges and bananas based only on their visible features. This is amazing for discovering hidden clusters in data, like figuring out different types of customers based on their buying habits. And the third flavor is reinforcement learning. This is all about learning by doing, through pure trial and error. You have an AI agent that exists in an environment, and it learns by taking actions. If it does something good, it gets a reward. If it does something bad, it gets a penalty. It's exactly like training a dog with treats. And this is the approach used for incredibly complex tasks, like teaching an AI to play a video game or training a self-driving car to navigate a busy street. Okay, so we've got the concepts down, but how does this actually go from a spreadsheet of raw data to a real working prediction? Let's do a quick flyby of the actual process. It really boils down to 4 main steps. 1, you gather and clean up your data. 2, and this is a big one, you split that data into 2 piles, a training set and a testing set. 3, you use that first pile, the training data, to train your model. And finally, step 4, you unleash your trained model on the second pile, the test data that it has never, ever seen before. This last step is absolutely crucial. It's the final exam. It proves that the model has actually learned the general rules and hasn't just memorized the answers from its study guide. Which, of course, brings us to a really important question. The model made some predictions on the test data. So what? How do we know if it's actually any good? We need a way to grade that exam. For that, we often use a tool called a confusion matrix. Now, I know it looks a little complicated, but the idea is actually super simple. Let's go back to our spam filter. A true positive is great. It caught a spam email. A true negative is also great. It let a good email through. The mistakes are where it gets interesting. A false positive is when a totally fine email gets thrown into your spam folder. We've all had that happen. It's so annoying. And a false negative? That's when a sneaky spam email slips past the filter and lands in your inbox.
That matrix lets us ask two really important questions. The first is precision. Precision asks, of all the times you cried spam, how often were you actually right? This is all about not making mistakes. Then there's recall. Recall asks, of all the spam that actually existed, how much of it did you manage to catch? This is about being thorough. And here's the thing, you often have to trade one for the other. For a spam filter, you want super high precision. You'd rather let one piece of spam through than lose an important email. But for, say, a medical model that's trying to detect a disease, you want incredibly high recall. You'd much rather flag a few healthy people for a follow-up test than to miss a single person who is actually sick.
So, why does any of this techie stuff matter to you? Well, because understanding the basics of machine learning is quickly becoming the same as understanding how our modern world actually works. This is so much bigger than just your phone. We're talking about medicine, where AI can analyze scans and spot signs of disease earlier and more accurately than a human can. We're talking about finance, protecting your accounts by spotting fraudulent transactions in milliseconds. It's breaking down language barriers with real-time translation and even helping to predict the chaotic swings of the stock market. This technology is a true game changer across the board. It really all comes back to this one powerful idea. Machine learning is what gives machines the incredible ability to learn from data, to learn from experience, and to find patterns and make predictions all on their own, with very little help from us humans. And so that leaves us with one last really big question to chew on. If our machines are learning from the data that we create, from our collective history, our choices, our biases, our behaviors, then what exactly are we teaching them about our world? And maybe more importantly, what are we teaching them about ourselves? Thanks for joining me.